guys, welcome to my YouTube channel. My name is Ranjiti. I am pursuing my BTech in Sri Venkateshwara College of Engineering. My section is Chevrolet. My library number is 23CS1659. Course code is BMATS101. The subject is mathematics. The topic I am going to teach is applications of polar coordinates. Applications of polar coordinates. First one, conversion between Cartesian and polar coordinates. It is derived from the Pythagorean theorem, where r is the hypotenuse of right triangle formed by the point and the origin. This formula gives the angle theta that the line connecting the original to the point makes with positive x-axis. The arctan is the function is used to calculate this angle. Polar to Cartesian coordinates. The given points r, theta in polar coordinates, you can find the Cartesian coordinates using these formulas. X equals to r cos theta, y is equals to r sin theta. The formula x equals to r cos theta gives the x coordinate of the point. It uses the fact that x equals to r cos theta in a right triangle. Y is equals to r sin theta gives the y coordinate of the point. It uses the fact that y is equals to r sin theta in a right triangle. Third one, distance formula in a polar coordinate. This formula is derived from the law of cosines and is analogous to the Cartesian distance formula. The formula to find the distance between 2 points in polar coordinates is d equals to square root of r1 square plus r2 square minus r2 r1 r2 into cos theta 1 minus theta 2. Fourth one, area in polar coordinates. This formula is derived from the formula of area of a sector in a circle. It integrates over the region described by the polar curve to find the total area. The formula to find the area in a polar coordinates is A equals to of integration from range alpha to beta f theta square into d theta. Arc length in polar coordinates. This formula calculates the length of a curve in a polar coordinates. It is derived from the formula arc length in the rectangular coordinates but adapted for polar curves. The formula to find the arc length in a polar coordinates is L equals to integrate range from alpha to beta square root of r theta square plus dr by d theta square into d theta. R equals to f theta from theta equals to alpha to beta. Sixth one, polar equation for common pairs. Various shapes can describe by polar equation. For instance, a circle with radius a is represented by r equals to a. The choroid, lemniscate, and spiral are the examples of polar equations representing specific shapes. Circle. The formula of circle is r equals to a. Lines. R equals to a sec of theta minus alpha. Choroid. R equals to a of 1 plus cos theta. Lemniscate. R square equals to a square cos 2 theta. Spiral. R equals to a e power b theta. Seventh one, complex numbers in polar form. A complex number z in polar form is given by equation z equals to r cos theta plus I sin theta. Here r is the magnitude of the complex number and theta is the argument and r is the magnitude, where r is the magnitude, theta is the argument. This representation is useful in complex numbers arithmetic, especially in a multiplication and division. That's all in applications of polar coordinates. Thank you. Do like, share and subscribe.